Hi, in this video we're going to be taking a look at this VTech video baby monitor. I paid £13 for this, plus about £3 postage off eBay as for spares or repair. I'll just bring the listing up so you can have a look. And it said in the listing that the camera wasn't talking to the screen. So let's get it out of the box and we'll have a look. We'll set it up and we'll see exactly what it's doing. So there's the camera part of it. And this little power supply. There's another power supply there, and this is the parent unit. A few scratches on the screen. Right, so let's plug this in. Just got an extension lead here, which I'll just use. That must be for the camera. Right, well, that part's lit up. Right, on-off button here, so we'll turn that on. Another little orange, there's a little orange light there, I don't know if you can see. Let's try and bring it a bit closer. Looks like it's got power. I'll turn that off. There you can see the orange light there. Make sure the baby unit is on. Move closer to the baby unit. Well, I don't think we can get much closer than what it is. We've got a reset button here. Oh, there's a little reset button there. We could try that. And we've got a little link button on here. We could try that as well. Let's wait for this to power back on. So I guess this has got some kind of little microcomputer inside of here. Might be interesting to have a look at that later. See exactly what's inside. Let's try going to settings, see if we've got a... Press and hold the pair button for 3 seconds until a beep is heard. Right, okay. Well, I'm not hearing any beep. So I'm thinking the problem's with the camera side of things. Right, I think what we'll do, we'll see where this part comes apart. I'll put this to one side for now. And I think we'll concentrate on this part, see exactly what's going on. But it looks like it's got power, because like I say, there's the orange light on there. You can just see it there. I'll just get this screen part out of the way. So it looks like we need to remove those 4 screws here. So we'll start removing those. I'll just zoom down a bit. So it looks like there's some kind of programming header on the bottom of this. So you can see 6 points there. So I guess that's for flashing firmware or diagnostics or something like that. Right, so how does this bit come apart then? Oh, bit severe. So what have we got in here then? Let's see, 3 LEDs. I guess that must be for the night light feature. That still doesn't really get wet into it. Over on this part of the board. I think it's a little NTC there for measuring the temperature in the room. And apart from that, not really a lot on that board. Right, so we've got 3 screws here. Let's see if we can undo those. Let's put those to one side. Well, we're making slow progress. I'm just going to unplug this connector a second. I'll try it out. There we go. And now we need to figure out how this part comes apart. I can see some clips just down here. I don't know how easy it is to unclip all of those. Looks a bit of a nightmare. So I think you've got to take the front off first, and that would give you access to these screws here possibly, or you could just squash those bits in. No, you can't squash those. Actually, maybe to squash that one in. Yeah, so I think you've got to separate this front part first, squash this bit in, and then it will come off from here. Right, let's see if I can figure out how to get into this part then. Let's try a different screwdriver. And there's some clips at the top as well. Once you get the top part off, zoom out a fraction. So it looks like we can undo those two screws now. And we're into it. The access still isn't great, mind you. Especially with those wires being on there. Let's just zoom down a bit and we'll just see if we can see anything. So an Ingenic T31 looks like the main controller here. It looks like we've got a Realtek Wi-Fi chip, flash memory, possibly audio amplifier, because that goes to the speaker, so maybe that's a little audio amplifier. And it looks like we've got a few little power supplies here. There's like one there, looks like one here, and one here. Looks like we've got a few 0 ohm resistors, which look like they're being used for fuses around the place as well. I can't see anything obvious at the moment. I can't see any burnt components or anything. Right, let's power it up. I'll tell you what I might do. I might check some of these 0 ohm resistors first, and then we'll power it up and we'll see what voltages we've got. Right. I might have to bring the microscope in for this one because it's a little bit small, and I'll not be able to get the meter in shot while I'm zoomed down at this level either. So I'll set the microscope up and then we'll come back once I get everything set up. Right, I've got the microscope set up. So let's try some of these resistors just to see if any of these are open circuit. It's really not the first one I've came across. Probably haven't got the probes on properly or something here. Yeah, I thought I was going to say, surely it can't be as easy as that. Never is. Right, so that one's okay. Let's try this one. Yeah, that one looks okay. Yeah, try that one. Yeah, that ductile doesn't look very straight. Another one here. Yeah, that one's okay. Another couple over here. Let's try this one. Yeah, that one's okay. Let's try this one. Right, so all those seem okay. I can't see any dry joints or anything. Maybe get some numbers off some of these chips. So that's an FM25S01A, which looks like some kind of flash chip. And this chip here, which I think could be an audio amplifier, is a 6306. See, that's the Ingenic T31, which I would think is the main processor. And it looks like we've got some kind of Realtek chip for the Wi-Fi, which is an 8189 FTV. Right, I think we'll hook it up to the power next and we'll see if we get voltages to places. Like I say, we mightn't be able to repair this one, but we'll give it a go. Right, so I've got it plugged in and switched on. You can see the little orange status light lit up there. So let's see if we can get any voltages on anything. So I'm going to use this here as a ground. Let's just try this capacitor first. And we've got 5.4 volts, so that must be the supply coming in. Let's see what we get on this capacitor. So 5.2, let's try this one. 2.8, so I guess that power supply there is probably working. Try and keep that ground wire on there. Let's see what we get on this one. I could try going on the inductor. Right, so we've got 3.3 volts on there. That must be to power the little Wi-Fi chip possibly. Yeah, 3.3 volts. We've got a couple of power supplies here. Let's see what we get on that. So 0.8 volts, so that might be like a core voltage for this IC. And let's try this one up here then. We've got a 1.8 volts. So it looks like we're getting voltages on all of the little power supplies. I'm going to grab the thermal camera. We'll see what the thermal camera shows up. Right, let's try the thermal camera, see if there's any shorts or anything obvious. Well, that doesn't look promising. It looks like the only thing that's getting hot here is the main processor. I mean, it's not excessively hot, but that's the only thing that seems to be doing anything. So I wonder if that IC has failed. I'm trying to think how we could determine that. What we might be able to do is hook the scope up and see if there's any activity on the flash. Because when you switch it on, the first thing it should do is try and load its firmware, I would think, from the flash chip. So I'll hook the scope up. I'll probably have to solder a ground wire on here just to make it a bit easier. And then we'll probe some of these pins on the flash, see if we're getting any activity. And if not, then I suspect the main IC has failed. Right, I'll set the scope up. Right, I've got this scope set up. So what I'm going to do is just switch this off a second. I'm just going to go on one of these flash pins here. We'll just see if we get any data or anything. See if it's actually trying to access the flash. And yes, we do seem to be getting something there. So I'd say that's trying to boot up that. I'm definitely getting activity on the flash. So I think that chip might actually be okay. Wonder if we're getting clocks on everything. Yeah, we're getting a clock on that one. Let's just try on here. Doesn't appear that we're getting any clock on the Wi-Fi chip. Looks like it goes to them two pins there. Might have to see if I can find a data sheet for this Wi-Fi chip, just to see what signals and that we're supposed to be getting there. But we don't seem to have any clock on there, so I'm just wondering whether the Wi-Fi chip isn't being initialized or something like that, and that's why it's just stuck in, you know, this mode here. Because there's two LED lights, so I presume one of them must mean it's operating and one means it's power or something like that. Right, I'm going to see if I can find a data sheet on this chip and then I'll be back. Right, I managed to find a data sheet on the chip, and there's two voltages going to the chip. There's one here, which is the sort of main power supply for the chip, so I'll just see if we've got any voltage on there. And yes, we do. We've got just over 3 volts there, so 3.5 maybe, 3.3. And there's another pin here which is the I/O power to the chip for the I/O pin, so I'll just go on that capacitor there, and yes, we've got voltage there. And these pins along here are the interface pins that go to the microcontroller. I think this one is clock. Let's just try that one. Yep, so that's the I/O clock which we've got. And I think the first two are something like reset, if I remember. So I'll do is I'll just try switching this off. I'll just go on to the first pin here, and I'll just switch it back on. And we've got power there. Yeah, and then it seems to have gone low and then high, so it looks like it's reset the chip. But I don't know why we're not getting any oscillation on the crystal. So I'm just wondering if the fault's related to this Wi-Fi module, because if it wasn't booting up, because if the Wi-Fi module wasn't initializing, it could be getting hung there and just being a loop or something. I wonder if there's any... I remember there was some pins coming down here going to the lower board for programming and that, so I wonder if there's any debug things on there. I'll just have a look, I'll see if I can find any debug pulses. I'll just unscrew this bottom piece here and get this little board out. Let's move this along a little bit, because we've got some test points here. I think I'll zoom out a fraction. Let's bring it down here. So let's try that one. That looks like some kind of clock. Right, well, there's something on that pin there. We seem to have some kind of data going on. Nothing on that one. That one just seems to be pulled up. I'm not sure about that one. Let's try just in the scale slightly. And we'll just reboot it one more time. So that one just appears to be a straight voltage. That's probably ground. Nothing on that one. That one just seems to be a voltage. But that one seems to have some kind of data going on it. So test pin 5. Nothing on 6. But there definitely seems... Oh, there we go again, there's some more data there now. I think what I might do, because I'm just wondering if this is some kind of serial data, I might hook the laptop up to this and we'll run a terminal program and we'll just see if there's any messages or debug messages come out of this. It might be quite interesting, that, and it might give her a hint as to what's going on with this. I'll go and get the laptop and we'll set that up. Right, back with the laptop, and I've got a little USB to serial converter, and I've just soldered it onto what I've worked out is ground and the pin that was given the signal out there. So we'll just go over to the computer screen I'll just switch this on. We'll just see what we get. Oh, it's spitting some things out. Was I hit backspace to, I think it was stop boot. But it's spitting out lots of information here at the moment. With a load of hex coming up there now. What's this? UBIFS error. Cannot read page 45. Right, I think this might be the problem. It looks like the firmware is corrupted on this. Let's go on again there. Yeah, cannot read page 45. So I wonder if we can get into this and, like, as a shell, because I've got the TX wire here, which lets me talk back to this, but I'm not sure which pin it is. So what I'm going to do is try it on some of the other pins here, and we'll see if we get anything on the screen when we type. Let's try this one. Oh, that was interesting. I've just touched that pin there, which is pin number 2, and it just came up the USB device. Let's try 3. Ah. So I wonder if pins 2 and 3 might be USB. Let's try pin number 4. Let's just try typing something. Right, well, I'm hitting Control C there, nothing's happening, but when I touch it onto pin 4, it was actually displaying it on the screen. There, if I disconnect the wire, it's not. So pin 4 must be the serial data in. I'll just switch this off a second and I'll solder those wires on, because one of my other wires just came off there as well. So I'll just unplug this from the computer as well, because I don't want to be soldering it while it's plugged into the computer. Actually, that should be alright. Right, let's get some solder, because I haven't got the computer plugged into a power supply, it's just running off battery. So oh, I didn't seem to like that. Right, let's try this one on here. So we might be able to flash this over USB or something, if I can find some firmware. Or it could be that the firmware chip has failed. Right, let's try switching it on again. Let's try hitting backspace. It didn't seem to do anything. And Control C doesn't seem to be doing anything now either. Right, let's try that again. I'll switch it off, I'll hold backspace down. I'll try switching it on. I'll try delete instead, maybe. I might have disabled the auto boot. Might have disabled the stop auto boot function on this. So I know it's one of the options you can do. Oh, something happened there. I might have just cleared the screen. Right, so this seems like a firmware problem, so I'm not sure whether we're going to be able to sort this one. I mean, we could buy a new replacement camera, remove the chip, read it, and then reprogram another chip and put it back in, or try reprogramming this chip, because the chip might be okay, and it might just be actually the firmware on it that's corrupted, rather than the chip failed. Right, I'll have a think on it. Well, I think things have just gone from bad to worse. I've just removed the circuit board from the housing here, and now it doesn't want to boot up. I'll just show you what it's doing. If I just switch it back on there, it just comes up that, and that's it. It just doesn't go any further now. I'll just switch it off and back on again. And all I've done is literally taken it out of the casing here, so I'm not sure what's gone on there. So I thought I'd have a look online to see if I could find a data sheet for the IC. And it seems like there's some voltages for the memory, which just seems to be where it's getting hung up on, seem to come in along the top of the chip, round about pins 79, 78 and 75. So I might go it under the microscope and have a look to see if we're getting voltages still on those pins. Right, got it under the microscope, and it looks like the voltage comes in on the top here, but I think I've just noticed what the problem is. It looks like when I've put a screwdriver under to get this board out, I think it's flexed the board. It looks like it's cracked this 0 ohm resistor, and I bet that's what feeds the RAM, the DDR power that goes in at the top of this chip here. So I think that's what the problem is. Or one problem anyway. We've still got the firmware problem, but at least I might still be able to resurrect this yet. So I'll replace that resistor, and then we'll try it again, and then we'll see if it boots back up the way it was doing before. So let's see if I can find a resistor. Right, so the only resistor I was able to find small enough to actually fit here was a 1 ohm resistor, which I think should be okay. I mean, it's only 1 ohms instead of 0 ohms, so, and it's only supplying the voltage to the RAM in here, so I wouldn't have thought it was going to take much current. So, right, I'll give that a go then, see if it starts booting up now. Right, I've got it hooked up again. Let's see if it boots up again now. Yes. Right, at least they're back where we were now then, so that's good. Right, I might try and hook up the USB on this to see if what happens when you connect the USB up on these pins. Yeah, I might find an old USB lead and connect that up and then see exactly what happens there. That might be interesting as well. So I did try connecting up a USB lead, but I think this is OTG USB. So I think this is actually for connecting a device, like a USB stick or something, to this, and for it to be able to read it. So one thing I have discovered though, which I'll just show you here now, if I switch, I went into the terminal settings, because I was wondering about this backspace. I've tried Control C, D, all the usual keys, and I was wondering about the backspace, and I noticed on my terminal settings it allows you to set something like either Control H or Control 128 for the backspace key. So I'll just switch this on a sec, and I'm going to hit Control H, and now we've got a prompt. If I type help, we've got some commands we can interact with now. So we've got things for setting the address offset, or boot Android system. Not that I'll have an Android system on this, I wouldn't have thought. Change the active partition. Calculate checksum. Environment, we can do things like print end, which will print the current environment and shows you the boot args for the Linux kernel and things like that. But that's as far as I've got so far, so I just thought I'd just give you a little bit of an update on how far we're getting. So I'm not sure whether any of these commands will be useful or not. It was possible to boot over USB or boot over serial or flash over serial as well. Yeah, load binary file over serial line. So I might have a look to see if there's any interesting files we can load into this and possibly even try and recover the data on the flash. If not, I might have to remove the chip, put it in the EEPROM programmer, and then see if we can do something like that. So I used the hot air rework station to remove the flash chip from the board, and then I used my XG ECU T48 programmer to read the chip, and then I refitted it to the board so I could do some more further testing. So I've been working on this for a couple of days now, and I'll show you where I'm getting up to. It's actually quite interesting. So this is my video editing computer, and I've got it running Linux at the moment from a USB bootable stick. And this is a terminal console that I've got connected to the camera via my little RS232 or USB UART, if you want to call it that. I'll just switch this camera on, and I'm going to stop it by pressing backspace just at this point here. And this is U-boot, which is the bootloader. This is the first thing that the camera does when you first switch it on. So I've been messing around with a lot of the commands on this. We'll just type help. I'll show you a list of all the available commands. And I've made a list of all of the ones that I've managed to get working. So there's a command here called mtd parts. So if I just type in mtd parts, it just displays that. If I do mtd parts default and then do it, you can see it displays a lot more information now. And these are all the different parts in the memory chip that's in the camera. We've got the U-boot, which is what we're using at the moment. Then we've got a Linux kernel. Then we've got a root file system. And then we've got another couple of partitions, one called VTech Data 1 and another one called VTech Data 2, which look quite interesting. So what I'm going to do first, I'm going to mount the partition called root fs, which is the root file system. So I'll type in that command there, and then this command here. And now what I can do, I can run this command here called ubi file system ls, which will allow us to see what files are in there. And then we can see there we've got some folders here, bin, dev, etc. Now the problem I was having was it's not easy to actually copy a file from here to anywhere. If we want to, let's say, go into etc, let's say, so if I just ls and then let's see, we're going to etc, and we want to have a look at the password file. Well, there's no real easy way to get the password file from here onto something external. So what I found out was we've got another command here called ubs fs load, and what that'll do, it'll copy a file from this file system into RAM at the specified location, which is here. So what I'm going to do, I'm going to get the password file there. We'll just copy that. I'll paste it. I'll just try that again. I know why I didn't put etc. Right, there we go. So it's loaded that file into memory, and then we can use memory display. I'll just copy the address, it'll be easier. And we'll just give it the size, just so we're not spewing loads of characters all over the screen. We'll hit enter, and there we go, we can see the contents of that file. Now if this was quite a large file, what I'd have to do is display it while capturing the terminal window here, and then save that to a file, and then use another program to convert that back into the binary file, which is a bit of a nightmare. I've actually done that once just to see if it would work, and it was very slow. It took about an hour to do one file, and it wasn't ideal. So let's try this shadow file. We'll just do the same thing again. I'll just change that to shadow, and there it's copied again, and then we should just be to do that. and it doesn't look like there's a root password set on this. So that's where I'm up to with this. So what I'll do, I'll try mounting one of the other partitions here. So we'll do this VTech Data 1. So I'll just issue this command. And then this one there. And now we should be to see all the files in there. And it starts getting a little bit more interesting now, because we've got things like setting files and configuration files and things. I can't remember which file it was. I think it was user settings maybe. So we'll try examining that file. I'll just paste that in there, and it's now loaded it. Now we'll just view it with the memory viewer. I just need to put the size in. And you can see there, but it's not ideal to view it, but it's got some interesting things in there. We can see the model number of the camera, we can see the vendor, we can see the serial number of the device, which is there, 2208 0008826, and that's what's written on the bottom of the camera. So I was able to access pretty much all of the files on this, so I'm not sure why we've got the file system error. Now, this is where it got a little bit more surprising, because I thought I was watching VTech Data 2. So if we just copy that, we'll just do the same again. We'll just mount that one, and then we'll mount VTech Data 2. And then we'll do this command here, just to view what files is in VTech Data 2. And we've got snapshot, record and thumbnail. So I thought, what's those? So if we have a look in snapshot, nothing in there. If we have a look in record, we've got loads of movie files. I thought that's a bit odd. I've got a load of movie files in there. And it turns out these are all recordings from the baby camera from the previous owner, which I was a bit shocked. I wasn't expecting it to contain all of these movie files. So I thought, oh, right, okay. But anyway, like I said, trying to extract any of these files was becoming a bit of a nightmare. So I had a look, and I spent another day or so figuring out how to actually mount it from the dump file that we extracted by reading the chip directly from the camera with the EEPROM programmer. So I'll get onto that bit just now. So in Linux there's something called NAND Sim, which is a NAND memory simulator. And what you can do, you can load a dump of a NAND chip into that and then run commands on it and extract files and things. Now I did try for quite a while to get that to work, and I didn't have much success with it. I was pretty much about to give up. And then I realised what the problem was. The flash data dump file that I had was of the complete flash, and NAND Sim needed it into partitions to be able to mount it. So what I did was I run up NAND Sim, I loaded in the whole flash chip data that I had, and then I saved parts of it at a time for all the different partitions, mounted it again with this command at the top here, which sets up all the partitions for it, and then wrote all of the partitions, mounted them, and then I ended up with all these folders. So I'll just show you what I've got here. Not that one. Here we go. So I ended up with the root file system, which is all of the files here. So we can have a look through all of those. So there's all of the files there for how this system starts up, and whatever. If we go back into VTech Data 1, you can see all of the settings here. So if I double click that one, you can see that file's a lot easier to read now. There's the serial number of the unit again. There's the model number. And then we can see all the other things a lot more better now, like, you know, temperature alert, state, last lullaby song, and all of the other parameters here. I'll just close that one down. Factory config, that must be for factory defaults. New temperature lookup table. So yeah, so I thought that was quite interesting. And then we've got the VTech Data 2. And if I go into record here, we've now got access to all of the videos of the previous owner. So I'll probably have to blur some of this out, but if I just click on, let's say, the first one here, as you can see, we've got picture from what it captured at the time when it was last used. And here's another example. So yeah, so I think there's a bit of a privacy issue there, especially if you've got one of these cameras and you sell it on eBay. It might contain a lot of the last recordings still. So that was one of the interesting things that I found anyway. Now I still haven't managed to figure out how to repair the file system and why it's crashing at that certain point. But what I did discover as well, in, I think it's VTech Data, actually it's in the root FS I think, there was this folder called Squash FS Images. And what that contains, we've got, this is where it downloads a firmware update. And we've got active, backup, and OTA, which I guess must be like over the air upgrades. So, this was just updated not long after the last images were recorded. So I think this is what's caused it to fail. I don't know if I can show the date on there. So the date on there was 20th of April 2023, and if I just go back to one of the recordings, '10th of April 2023. So not long after these recordings were recorded, that's when the firmware updated, and then we haven't got any other recordings after that. So I've got a feeling that's when the problems have occurred. So this Squash FS data, I actually extracted that, unsquash FS'd it, which is a file system within this file system, and we managed to extract all of the files out of that as well. And this is where the main camera application is. So this is it here, VT Cam, which is the main program that runs the camera. And then we've got all these other little things like the little melodies it plays, and things like when it tells you the camera's ready to use. If I just double click on that.
The camera is ready to use.
Oh, we've got some different songs there, we'll try that. So that's one of the lullabies it must play. What else have we got? Boot script. So if I open up that one, this is what it does when it first boots up. So we can see here where it says echo run boot script with a lot of minus signs before it. So if I just switch the camera off, because this is still connected to the console here, if I switch this off and back on and let it boot up a bit, I'll just have to switch it off again and then rewind it a bit when it starts coming back up with those errors. That'll do. So if I go back here, there we go, we can see there, run boot script, which is this bit here. So we know it's actually getting this far in the program as it's booting up, and then we can see where it says some other things here, like where is it, user setting intact, And if we go down here there, you can see there, user setting intact. So like I said, I still haven't figured out why it's not booting up properly yet, but this is what I've managed to achieve so far, and I think it was quite interesting, so I hope you found this part interesting too. Right, I'm back with a bit of an update here now. So I thought I've got a backup of everything. If I destroy the flash, if I erase it or whatever, then it's not going to make any difference. I've got a backup of the dump file in any case, so I could always restore it and have another go. So I thought I'd issue a few commands here. So what I did was I did the mtd parts default, and we'll just do mtd parts just to show all the different partitions here. And I thought, let's erase all of these images and video files just to see if that made any difference. So I issued this command here, and erase, and you dot part, which is for partition, and we'll just give it the name of the partition we want to erase, which is VTech Data 2. I'll just hit enter, and you can see it erasing that partition. So that partition is now empty. But now we need to recreate the partition. So what I'll do is I'll just issue this command, which is UBI part for partition and VTech Data 2. So we'll just do that. And that's it, recreated. Right, okay. So that partition now is just totally empty. Hasn't got any files anymore. All those video files of the previous owner have now gone. I'll just switch it off. And I'll just switch it back on. And you can see it booting up there now. I didn't seem to get any error. And if I look at the device now, just down here, I'm going to see it's all lit up. It's actually got the night light lit up, which it's never done before. So I think we might have fixed it. So what I'm going to do, I'm going to get it. It's been about 3 days I've spent on this, fixing a bloody baby monitor, believe it or not. But sometimes I just get engrossed in things like this, and you know, I just find it a bit of a challenge. You know, I don't think there'd be many people be able to do it, like stuff like this. But I hope everybody found it as interesting as what I did, and the potential video files and things even stored on this device, which I don't know whether anybody was aware of. So, right, I'll get it on the blue mat, we'll get it back together, and then hopefully we'll see if it's working. Right, I just noticed when it was booting up there was an error saying VTech Data 2 didn't exist, and I forgot to issue this command, which is UBI create. So that's to the list of commands there. So if anybody else has got one of these and they want to know how to fix it, issuing those 4 commands there, and I'll show the pinout of the RS232 interface on the bottom of it. Once I get it on the blue mat, I'll take a picture and I'll do a little diagram so you know how to wire one of these up. So if you want to repair it yourself, you now can. Right, so these are the pinouts of the UART port on the bottom of the device. This one here is ground, this one here is data out from the device, and this one here is data into the device. These two are USB ports, and I think that's for an OTG USB for connecting, let's say, like a memory device, like a memory stick or something to it, and then you can access that through U-boot and copy memory from one device to another. And this one's VCC. So these pins here, you could actually access them using pogo pins through this little arrangement on the bottom of the camera here, and you wouldn't even have to take the device apart. Right, let's continue reassembling it then. So I think I'm done with these wires now, so I'm going to remove them. Just clean up that little bit of solder there. There we go. Right, so now I've got to figure out how this goes back together now. So obviously that went on there, like that way. And that's the little temperature sensor here. I think I've already mentioned that before. think I'll put this camera part back together now. You can see where I've soldered the flash chip back into the board there. Now, because it's been a few days since I took this apart, I'm trying to remember how it went back together. Right, I figured it out. Yeah, that goes into this little peg here, and then this bracket turns, and you put 2 screws in it. I thought there was another bracket, but it's just this one wasn't turned the right way. Right, we've got this bit to go on, so I think I need to unplug this for now. And that's got 3 little bits that line up here. Let's get this USB converter out of the way. That's the, just in case you're interested, that's the USB to TTL converter that I was using. I've had this quite a while. I've got a couple of them, so they come in very handy, especially for things like this. Let's check. Got the on-off switch in position. And the other buttons still click. It's a bit awkward to assemble this, mind you. There's a little clip I've noticed just down here, which I think has got to go underneath that bit of plastic. So I'm going to try and get that in. It just makes it all a bit more awkward. There we go. Just the 4 screws to go in the bottom now. Right then, let's plug it in, and hopefully it should light back up in a minute. Let's move these screwdrivers out of the way. Oh, there we go, we've got a nice red glow on it now. We never had that before. Right, I'll just grab the monitor. And now we'll switch that on. And hopefully it connects and it all works. But I was really surprised that it actually had data still on this. So it just goes to show you, if you dispose of anything on eBay, but I don't know how the user would even know that there was data stored on there. I mean, I was quite surprised, so I'm sure they would be. And it looks like we're in business. I'll try a picture of the oscilloscope or something there. And there we go. And there's the microscope. Right, excellent. Let's just try some of the other functions. Let's just see. I'll just angle this over a bit. You can look at my fluorescent light, or my LED light. If I just go into the menu here, let's try changing the LED colour. Let's see what colour 3 is. Yeah, that seems to change colour. I don't know what number 2 is. I wonder if you can set custom colours. No, it doesn't look like you can. Alright, melodies. So these should be the OGG files, I think that they were, that I discovered in the file system. So let's try this one. Yeah, and that's the same song that was playing. Right, we'll just stop that. And what else have we got? So we've got something here called motion. So I guess these guys must have had it linked to the internet and were able to retrieve the images on their phone. And I think that's why it stores the images in the camera. So if you're not using the monitor and you're connecting to it via your phone across the internet, for instance, then it might store the images on the camera rather in the cloud somewhere. I don't know which would be the better option, but looks like the quality's actually degraded slightly there. Wouldn't exactly say it's HD, but Alright then, well, I hope you found this video rather interesting, because it was a fair bit of work. So if you enjoyed this video, please give it the thumbs up. If you want to see more like it, please subscribe. Any comments or questions, please leave it in the comment section below. And as always, have a great day. Thanks for watching. And don't forget to give it a thumbs up.